Hello everyone. So we are going to the last part of the chapter. So this is what we call the average value of a function. Average a value of a function. Actually, we discussed this section, this topic before, so you can watch that one also if you want, but this is like a simple idea. So since we discussed earlier, I'm not gonna go too much deep into it here. So let's look at what we are trying to do here. So let's say you have a graph, let's say something like that. This is going from A to B. So what we're trying to do, so this graph has a area below the curve. So that's the area. You can see there's an area below the curve. So what we're trying to do, we try to find a rectangle which has the same width but some kind of height. So for example, this rectangle and this rectangle and the area under the curve has the same area pretty much. Okay, so those two are equal. So what you try to do, so you try to find a rectangle which has the same area as the area of the curve under the area of the area under the curve. Okay, so that's what we're trying to do. So so in this case we have y equal fx. So the area below the curve from A to B is exactly equal to the area of the rectangle. So see this value what we normally call f average, f avg. So the formula is f average is since the area of the area below the curve is the integral and then the area of the rectangle match. So what's going to happen, so if you multiply the average value with the width, you should get the area of the area below the curve. So that means it is 1 over b minus a, the integral a to b fx dx. Okay, so that is a very simple idea, and we assume that this is integrable, or like you can integrate this one. Okay, so that's the formula. So it's very simple formula. So that's the first result. So this is the average value. So we say f avg, the average. And then we have a theorem. That's the only theorem we have in this section. What it says that the mean value theorem. So the mean value theorem for integrals. So mean value theorem, mean value theorem for integrals. Mean value theorem for integrals. So what it says that if the function is continuous, then you can find a value of the you can find a value for example here the value c, such that the value of the function is exactly equal to the average value. So that is the fc. So that's what it says. So there is a value at which the function value is exactly equal to the average value. Okay, so it says that there is. So I say actually I'm gonna write it like that. So what is the condition? So the condition is if continuous. If f is continuous, then there is a value. There is a value c in a and b such that fc is exactly equal to the average value of the function, or the integral that we just discussed. So that means it is simply 1 over b minus a to b fx dx. That's the one we just heard. So what it says that there is a c in the interval such that it's going to give the exact value as average value. So that's what we call the mean value theorem for integrals. Okay, so there is, it doesn't tell you how to find it, we say there is. So what we normally do is we can set that value equal to the function, solve for c. Okay, so what we normally do is solve for c. Okay, so let's just do one example just to kind of get the idea. So yep, so how about this one? So let's say so find the average value, find the average value of the function f x equal 1 plus x squared on the interval -1 to 2. Okay, and then also find c in the interval -1 to 2 such that if c equals the f average. Okay, yeah. So the answer, so this is like a simple problem. So what we're trying to do, f average is 1 over b minus a to b fx dx. So let's plug in. So it is 1 over, what is b? B is 2, a is -1, and -1 to 2, 1 plus x squared dx. So so which is 1/3. The integral is x plus x3 over 3 to -1, and then if you plug in the values, you're going to get 1/3. If you plug in 2, how much you get if you plug in 2? So you're going to get 2 8/3, so you get here 2, so you get 6 14/3 minus, and then if you plug in -1, so you're simply going to add, so you're going to get 4 4/3. Okay, so so you're going to get 18 over 9. Okay, so yeah, so so you're going to get 18 over 9, which means 2. So the average value is 2. That's the first part. The second part, also find c such that it's equal to the average value. Okay, so since we know the function, so let's see. So by mean value theorem, there is c such that if c equal to but f is, so it is a c, so it's a c squared plus 1 equal 2, so this can give you c squared equal 1 and c equal plus or minus 1. And then but you can see that the both of the values are in the interval -1 to 2, so that means there are two answers, so c equal plus or minus 1. So those are the two answers. Okay, so you can see that's that's not that difficult. So let's just do one more example, since we, yeah, so so find the average value of f equal, let's say cosine 4x sine x on, let's say from 0 to pi over 2. Okay, from 0 to pi over 2. So again, by the definition, so it is the f avg is 1 over b minus a to b fx dx, so which is 1 over b minus a, it is pi over 2 minus 0, and then 0 to pi over 2 cosine 4x sine x dx. Okay, now the problem is how to integrate this problem, how to integrate this one, how to integrate this this integral. So you can see that you have to, because you're going to see the function and a derivative, so that means you're going to use the substitution method for this problem. So I'm going to pick u equal the inside function, that is cosine x. So that's what I'm going to use. So you always need to figure out the inside function and its derivative. So if you take the derivative of this one, it is negative sine x dx. So we already see the sine x, negative sine is you can manage. So that means dx sine x dx is simply negative du, right? So that means here it's going to happen 1 over pi over 2. And then also you need to find the new limits. So let's try to find the new limits. When x equals 0, u equal, how much you get? When you play x equals 0, u equal 1. When you play x equal pi over 2, u equal cosine pi over 2, which is 0. So that means it's going to be 1 to 0. This become u, so it's a u to the 4th. And then sine x dx is simply negative du. So you can put the du and the negative sign outside. So you can integrate. This is very easy to integrate. So it is simply negative 2 over pi. It is u 5 over 5 0 1. And then you can plug in the value. So it is negative 2 over pi. So you plug in 0 and then minus 1/5. So if you simplify, you're gonna get 2 over 5 pi. So that is the answer. So some of the problems you might have to use the substitution method. So this is a very common technique that we use. Okay, so that's the end of the section. So it's like very short. So you can start working on the problem, but make sure that you use the substitution method for some of the problems. That's like a general technique. But formulas is very simple. You just use the formula 1 over b minus a to b fx dx. Okay, so that's it.